and welcome back. I'm Abigail, and today we're going to be looking at a few things. We're going to be looking at 30, 60, 90 degree right triangles, and we're also going to be looking at 45, 45, 90 right triangles and seeing how the ratios of these sides work. Okay, let's jump in with a 30, 60, 90 degree right triangle. Essentially, when we're looking at a 30, 60, 90 right triangle, we're given three angles, right? We're given an angle over here of 90, we're given an angle of 60 degrees, we're given an angle of 30 degrees. And we know that 60 plus 30 plus 90 equals 180, right? And we also know the rule that the sides of the triangle have to add up to be 180 degrees. So great. We have a triangle that we're looking at, it's a right triangle. But also, because it's a 30, 60, 90 degree right triangle, we know something else. We know that the sides are going to have a special relationship to one another. And that's a relationship that we can know and we have to memorize. Essentially, we have this angle of 90, right? Right here. Okay, that's a 90 degree angle. When we look across, we see a hypotenuse, right? The hypotenuse is just the side of the triangle that's opposite the right angle. And the measurement, or the side ratio of the hypotenuse in a 30, 60, 90 degree right triangle is 2 times x. X is just a variable. X could represent absolutely anything. It doesn't matter, okay? So that's going to be 2 times x. Now, if we go to the 60 degree angle and we look across, okay, what do we have? Well, we have x times the square root of 3. Essentially, it's just some number x times the square root of 3. And that's going to be that side opposite the 60 degree angle. What about with a 30 degree angle? With a 30 degree angle, we look across, we see the x. The x can represent any value, but essentially we see that all the sides are in proportion to one another based off of this value x. And the x has to be the same for all of them, obviously, because it's a variable. But the variable has to remain constant for the problem. So maybe that will make a little bit more sense if we try it. So let's go ahead and jump down to try it and see what we're asked. Okay, so the problem asks us to find the remaining two side values of the triangle. And that might seem hard, right? We're only given, well, we have this 90 degree angle here, and we have the 60 degree angle here, and we're given a side of 4. Okay, let's start by thinking about what that third angle right here of this triangle would be. Well, the third angle of the triangle, we have a 90 degree angle, we have a 60 degree angle, we have something else, and that's supposed to equal 180. Well, that's going to be pretty good because 60 plus 90 is 150. 150 plus some value, some degree value is equal to 180. Well, we know that the third degree angle is going to be 30, and that's based off of that knowledge that all the angles in a right triangle have to add up, or sorry, all the angles in a triangle, rather, have to add up to be 180 degrees. So now I know we have a 30 degree angle. Well, now look at this. This is exactly how to approach these problems. Now we know that we have a 30, 60, 90 degree right triangle, right? We have 60, 90, 30. Great. Well, now what we know is we can use our knowledge from here and bring it down, okay? Also note that sometimes the triangles won't always be set up just like this. You know, these are set up like each other. Sometimes that won't always be the case. So just keep in mind that opposite the 60 degree angle, x times the square root of 3. Opposite the 90 degree angle, 2x. Opposite the 30 degree angle, x. That's all you needed to remember, okay? If it's not set up in the same way, just keep that in mind. All right, so we have a 4. Okay, so we're given this number 4. We also know that 4, because it's opposite the 90 degree angle, well, that ratio, just look up here, is going to be 2x. That's the value of the side. So we set 4 equal to 2x, and now we're just doing a simple algebra problem, divide by 2 on both sides. X would be equal to 2. So now we have that value of x, okay? Well, that's really helpful because we have to base everything else in the problem off of this x. Okay, so now we know that x is equal to 2. Well, where else? Well, okay, so now let's work our way around. What about the side here opposite the 30 degree angle? What's that value? Oh, look at that. The value opposite the 30 degree angle is x. So all we have to do is we have to say, oh, well, x is 2. Look at that. Put in a 2. Now, what about opposite the 60 degree angle? That's x times the square root of 3. It's not hard, I promise. All you have to think about is, what's x? Our x value is 2. Okay. Now it's just going to be x times the square root of 3, or 2 times the square root of 3. And guess what? We just found out the remaining two side values of the triangle. We have a 4, a 2 times the square root of 3, and a 2. That's pretty fancy, okay? So it really wasn't that hard of a problem. All we had to know is that opposite the 60 degree angle, x times the square root of 3, opposite the 30 degree angle, x, opposite the 90 degree angle, or the hypotenuse, is 2x. That's all we had to know. And then we had to find x based off of what we were given in the problem, right? We were given the side value of 4. Well, we know that 4, the ratio of the hypotenuse in a triangle is going to be 2x. We set 4 equal to 2x. We solve for x, right? So we might not always know the exact values, but we know the ratios. Okay, so we know that it's not going to be 4 for every single problem, right? Like the value here is not always going to equal 4, but we do know that the value will be proportional to 2x, and that's what we can say, well, 4 equals 2 times x, and then we solve for an x value, and that x value ends up playing out in the rest of the problem for us. Okay, that's a 30, 60, 90 right triangle. The key here is that you need to memorize this chart here. Okay, memorize that angle goes here, this angle goes here, this angle goes here. Take note of that and you will be set. Let's move on to 45, 45, 90 right triangles. Okay, so in a 45, 45, 90 right triangle, we're given an angle of 90 degrees, we're given an angle of 45 degrees, and well, we know that the last angle is going to be 45 degrees too. That's the 45, 45, 90 right triangle. Okay, and so the ratio of the sides we see here, well, because these two angles, this angle and this angle are the same, it ends up being that they have the same proportions. So across from the 45 we have an x, across from the 45 we have an x. Okay, so those are actually going to be the same in value, and then across from the 90-degree angle or the hypotenuse, this here is the hypotenuse. It's across from the 90-degree angle, the hypotenuse of a triangle, whether it be a 90-degree right triangle, an acute triangle, a triangle with the largest side or the largest angle being less than 90, or an obtuse triangle, a triangle with the largest angle being greater than 90 degrees. Regardless of what it is, the hypotenuse is always going to be the side opposite the largest angle. So keep that in mind. The other two sides are actually called legs. This is a leg of the triangle, and this is a leg of the triangle. And then right here, this is the hypotenuse. Okay? Good terminology to know about triangles. Okay, so where were we? Well, we were talking about this right here being opposite the 90-degree angle. So again, it's a ratio of the sides, just like we had discussed previously. And across, we have an x times the square root of 2. So that's simply something you have to memorize. You have to memorize that across from a 45-degree angle, this only works when it's 45, 45, 90. Okay, but both sides, or all angles have to add up to 180. That's a triangle. But also the angles have to be 45, 45, 90, and then this works. So if you know that, then you're set. But it's going to be side values in a ratio, right? In a ratio, because we don't know the exact values, but we do know the proportions because we're given these x values, and the x's are all going to be equal in the problem because, again, it's a variable, but the variable will remain constant as a value when you find out what the variable is for a problem. So you start looking across here, you look across here, you look across there, and you find out that we have x, and then x times the square root of 2. Okay? So someone much smarter than us was able to figure this out, and now we can essentially use this to our advantage. Okay, so let's try it, because I think that'll help make more sense. I'll leave this diagram up here for you to look at if you want. All right, so let's say that we have a 90, well, that's just a right angle, and let's say that we're given a side angle of 45 degrees, and we need to find this side, and then this angle right here. Okay, well, what are we going to do? Well, the first thing is, let's try to find this angle. So we know that we have a 90-degree angle plus a 45-degree angle plus some other angle we don't know, and that's going to equal 180. Well, guess what? All the sides of a triangle, all the angles of a triangle have to add up to 180. That's why I'm setting this equal to 180, right? So now it's just simple algebra, and we solve, and we would find that last angle is 45 degrees. Okay, 45 degrees. Look at that. Look at what's happening now. I have a 45, 45, 90-degree triangle. Well, that's really handy, because in that case, I know that I'm going to be able to use my side ratios. Okay, great. So let's start, first of all, by looking at what x would be equal to, because we need to know x in order to complete the rest of the problem. All right, so we have across from a 45-degree angle, we have a 5. And what's the value across from a 45-degree angle? Up here? Okay, up here. I'll write this in red so you can see it. Up here. Well, it's x. Okay, that would mean that 5 would be equal to x, right? We're talking about ratios here. So we're just going to set this equal to that, and then we can solve for x. Great. 5 equals x. Well, that's really helpful, because then what else do we know? We know across from the other 45-degree angle, it's the same thing. That's also going to be 5, right? Because we know from up here, the other 45-degree angle also has a value of x. So that's awesome. Made that simple for us. Okay. And then we need to know the last one, which is going to be right here. What's this called? This is the hypotenuse, right? Because it's across from the largest angle of the triangle, being 90 degrees. Okay, what's that going to be across from here? What do we know? X times the square root of 2. What's x? X is 5, and the square root of 2 is just the square root of 2. So we get this 5 times the square root of 2, and now we learned that we have a 45, 45, 90, and we figured out what the remaining two sides were, 5 times the square root of 2 and 5. Okay, so that's essentially how you look at these problems. It's quite simple. Essentially, all you need to know is right here, right? You need to know the ratio of the sides, x times the square root of 3 and 2x, and exactly where it's fitting across from each angle, right? So you need to know that across from the 30-degree angle, you're going to have a side ratio of x. Across from the 60, you're going to have x times the square root of 3, and across from the 90, you're going to have 2x. So you have to memorize that. And then down here again, you have to memorize that across from the 45-degree angle, either one of them, it's going to be x. It works the same way for both of them. Across from the other 45, x again, and across from the 90, x times the square root of 2. If you can memorize that, you'll be able to apply it, and it ends up making math so much easier. All right, guys, thanks for listening.